So we're going to do the same thing. The difference with this is that we do have a heteroatom. So that changes just a little bit. Again, if you want to go ahead and draw the skeletal structure for this, you are free to do so. Or hit pause if you want to go ahead and try yourself. Otherwise, I'm going to go ahead and go to the solution slide and get started. So honestly, my strategy is still the same. I'm still going to go ahead and get rid of my hydrogens. So all of the CH3 or methyl groups, and there's a methine carbon right there, I'm going to go ahead and get rid of them because I know I don't care about hydrogens. I'm not going to see them. So I have my carbons left, but again, I have an oxygen right here. So based off the previous problem, I know that all of my corners or mountaintops and valleys are carbons. How would I represent the oxygen? Well, you would just write this atom. So carbons and hydrogens are the only elements that we do not write out. So anytime you have something like hydrogen, we're not going to draw it. Anytime you have a carbon, we are not going to draw a C anywhere. But all other atoms, yes, we're going to put an O for oxygen, we're going to put N's for nitrogens, and so on and so forth. Okay, so with that in mind, I'm going to go ahead and number because, again, numbering, oh, goodness gracious, I'm just making a mess. Numbering just makes things a lot easier to see as you're going. So I have 1, 2 carbons, and then I have the oxygen, and then 3, 4. Now, I'm not ignoring the carbons that are up here. I just like to number in a straight line. If you want to number those, you are free to do so. I just don't. Whatever works for you. So based off what I just numbered, I know that I should have my 2 carbons. So there's my 1, 2. And then, oh, that's interesting. And then I should have my oxygen coming off of carbon 2. So why does that keep happening? Oh, technology is lovely, and then it's not. Stop. There we go. Okay, and so, oh, I understand. Okay, so I'm going to draw my 2 carbons here. So there's 1, there's 2. I know that my oxygen is coming off of 2. All right, so that's how I represent my O. And then I have a bond to carbon 3, and then I have my carbon 4. All right, so this is how we would introduce a heteroatom to our skeletal structure if it is in the middle. Now, we know we're not done because we still haven't put in the carbons that are up here. So at this point, we know we have branching because we don't have just a straight line like we did in problem 1. We have stuff coming off. So we can see that we only have 1 carbon coming off of carbon, what I've labeled as carbon 2. So I should only have 1 carbon coming off of carbon 2. So that is going to be our methyl or CH3 group coming there. I don't have to draw anything else because, like we talked about, this one little corner is representative of that carbon. So, and now we have our 2 methyl groups or CH3 groups coming off of carbon 3. So I need to show that carbon 3 has 2 additional methyl groups or 2 additional carbons. The way I'm going to do that is the exact same way I did carbon 2, where I'm just going to draw 1 line coming off, and then I'm going to draw a second line because these carbons are not connected to each other. So I should not draw it, let's say, if I do something like this. So if I get here, if I draw this, that is not correct because I don't have a carbon or a CH2 and then a CH3. I have 2 CH3 groups that are separated. So that is why this would be considered incorrect. All right. Now, something I do want to point out is I see sometimes students get confused with this little ending right here. I sometimes see students think that that is a carbon. It is not. Like I pointed out before, this line right here is the bond. All right, so the bond here is between the carbon and oxygen atoms only. Okay, so I'm going to clean this up. So our answer to this should be the following skeletal structure. So this would be the answer. And you do not have to put lone pairs on oxygen. We know that we have 2 lone pairs here. They are implied when we draw line angle structures or skeletal structures, so it's your personal preference. I usually don't. Like I tell my students, organic chemists are going to be the laziest chemists you ever meet.